The area surrounding the natural gas storage tank is classified based on the potential for explosive gas mixtures to be present. The classifications are Class 1, Division 1, Class 1, Division 2, Zone 1, and Zone 2. Class 1 refers to locations where flammable gases or vapors are, or may be, present in the air in quantities sufficient to produce explosive or ignitable mixtures. Division 1 indicates a location where an ignitable concentration of flammable gas or vapor exists continuously, intermittently, or periodically under normal operating conditions. Specifically, within 10 feet of the vent or relief valve of the tank and within 5 feet of the ends or sides of the tank, it's considered Class 1, Division 1. Division 2 indicates a location where an ignitable concentration of flammable gas or vapor is not normally present in the air, but may become present accidentally. This zone extends 15 feet from the tank in all directions. Zone classifications are similar but used in a different system, often aligned with international standards. Zone 1 indicates a location where an explosive gas atmosphere is likely to occur in normal operation. This is within 10 feet of the vent or relief valve, and within 5 feet of the ends or sides of the tank. Zone 2 indicates a location where an explosive gas atmosphere is not likely to occur in normal operation, and if it does occur, it will exist for a short period only. This also extends 15 feet from the tank in all directions. To protect electrical equipment in this hazardous environment, rigid conduit is essential. It should be installed along the 15-foot concrete wall on the opposite side of the tank. The purpose is to provide a robust and sealed pathway for electrical wiring, minimizing the risk of ignition in case of gas leaks. Now let's talk about generator placement. Section 500.8 A2 of the National Electrical Code, or NEC, provides guidance on this. It generally requires that generators be installed at least 10 feet away from buildings and other structures. However, this distance can be reduced to 5 feet if the generator is enclosed in a weatherproof housing and has an emergency shutdown system. This is because a weatherproof housing helps to contain any potential sparks or flames from the generator, and an emergency shutdown system allows for quick power cutoff in case of a hazard. Additional considerations are important for a safe operation. Firstly, ensure that all electrical equipment used in the classified areas is properly rated for Class 1, Division 1 or 2 and Zone 1 or 2 environments. This includes motors, lighting fixtures, switches, and any other electrical components. Secondly, provide adequate ventilation in areas where gas vapors may accumulate. This can help to prevent the buildup of explosive concentrations of gas. Thirdly, train personnel on the potential hazards of the natural gas processing plant and the emergency procedures to follow in case of a gas leak or other incident. This training should cover the use of safety equipment, evacuation procedures, and first aid. Fourthly, regularly inspect and maintain all equipment, including the storage tank, electrical equipment, and safety systems to ensure proper operation and safety. This includes checking for leaks, corrosion, and other signs of damage. Remember to always consult with experienced engineers and review relevant industry standards and regulations for the specific requirements of the natural gas processing plant. This will help to ensure that the plant is designed, constructed, and operated in a safe and compliant manner. The NEC is a critical reference for electrical installations in hazardous locations. It provides detailed requirements for wiring methods, equipment selection, and grounding. Some important sections to review include Article 500, which covers hazardous locations, and Article 505, which covers zone classifications. In addition to the NEC, other industry standards and regulations may apply, such as those from the American Petroleum Institute, or API, and the Occupational Safety and Health Administration, or OSHA. These standards and regulations provide guidance on the safe design, construction, and operation of natural gas processing plants. The selection of appropriate electrical equipment for hazardous locations is crucial. Equipment must be specifically designed and certified for use in the class, division, or zone in which it will be installed. This equipment is typically explosion-proof or intrinsically safe. Explosion-proof equipment is designed to contain any explosion that may occur within the enclosure, preventing it from igniting the surrounding atmosphere. Intrinsically safe equipment is designed to operate at low voltage and current levels, reducing the risk of ignition. Grounding is also a critical aspect of electrical safety in hazardous locations. Proper grounding helps to prevent the buildup of static electricity, which can be a source of ignition. Grounding also provides a path for fault current to flow, which can trip a circuit breaker or fuse and de-energize the circuit. Ventilation is another important safety measure. Adequate ventilation helps to prevent the accumulation of flammable gases or vapors in enclosed spaces. Ventilation can be achieved through natural means such as open windows and doors, or through mechanical means such as fans and blowers. Gas detection systems can be used to monitor the concentration of flammable gases or vapors in the air. These systems can provide an early warning of a potential gas leak, allowing personnel to take corrective action. Emergency shutdown systems are designed to quickly shut down the plant in the event of a gas leak or other emergency. These systems can be activated manually or automatically by gas detectors or other sensors. Regular inspections and maintenance are essential for ensuring the continued safety of the plant. Inspections should be conducted by qualified personnel and should cover all aspects of the plant, including the storage tank, electrical equipment, and safety systems. Maintenance should be performed on a regular schedule and should include tasks such as lubricating equipment, replacing worn parts, and testing safety systems. Training is also an important aspect of safety. Personnel should be trained on the potential hazards of the plant, the proper use of safety equipment, and the emergency procedures to follow in case of a gas leak or other incident. Safety audits can be conducted to assess the effectiveness of the plant safety program. These audits should be conducted by qualified personnel and should cover all aspects of the plant safety program, including training, procedures, and equipment. Consider the specific properties of the natural gas being processed when determining the hazardous area classification. The flammability and explosivity of the gas will influence the extent of the classified areas. Also, consider the potential for leaks or spills from piping, valves, and other equipment. These potential leak sources should be taken into account when determining the hazardous area classification. A hazardous area classification drawing should be prepared to clearly delineate the boundaries of the classified areas. This drawing should be reviewed and updated as necessary to reflect any changes to the plant. The hazardous area classification should be based on a thorough engineering analysis taking into account all relevant factors. This analysis should be documented and should be available for review by regulatory authorities. When selecting electrical equipment for hazardous locations, be sure to consider the temperature rating of the equipment. The temperature rating should be high enough to prevent the equipment from becoming a source of ignition. Also, consider the ingress protection, or IP, rating of the equipment. The IP rating indicates the degree of protection provided by the enclosure against the ingress of dust and water. When installing electrical equipment in hazardous locations, be sure to follow the manufacturer's instructions and all applicable codes and standards. Proper installation is essential for ensuring the safety of the equipment. When performing maintenance on electrical equipment in hazardous locations, be sure to de-energize the equipment and follow all lockout/tagout procedures. This will help to prevent accidental ignition of flammable gases or vapors. When working in hazardous locations, be sure to wear appropriate personal protective equipment, or PPE, such as flame-resistant clothing, safety glasses, and gloves. PPE can help to protect workers from potential hazards. Be aware of the potential for static electricity buildup in hazardous locations. Static electricity can be a source of ignition. Take steps to minimize the buildup of static electricity, such as grounding equipment and wearing anti-static clothing. Develop and implement a comprehensive safety program for the natural gas processing plant. This program should cover all aspects of safety, including hazardous area classification, electrical safety, fire prevention, and emergency response. Regularly review and update the safety program to ensure that it is effective and up to date. Ensure that all personnel are familiar with the safety program and their roles and responsibilities. Conduct regular safety meetings to discuss safety issues and to promote a culture of safety. Investigate all incidents and accidents to identify the root causes and to prevent recurrence. Learn from the experiences of others by sharing safety information and best practices with other natural gas processing plants. Work with regulatory authorities to ensure that the plant is in compliance with all applicable codes and standards. Continuously strive to improve the safety of the natural gas processing plant. Consider the use of remote monitoring and control systems to minimize the need for personnel to enter hazardous areas. These systems can allow operators to monitor and control the plant from a safe location. Consider the use of wireless communication systems to reduce the amount of wiring required in hazardous areas. Wireless systems can simplify installation and maintenance. Consider the use of fiber optic cables for communication and control signals in hazardous areas. Fiber optic cables are immune to electrical interference and do not pose a risk of ignition. Consider the use of purged and pressurized enclosures for electrical equipment in hazardous areas. These enclosures are designed to prevent flammable gases or vapors from entering the enclosure. Consider the use of intrinsically safe barriers to limit the amount of energy available in electrical circuits in hazardous areas. These barriers can prevent ignition even if a fault occurs. Consider the use of non-incentive equipment in hazardous areas. Non-incentive equipment is designed not to produce sparks or hot surfaces that could ignite flammable gases or vapors. Consider the use of reduced voltage starting for motors in hazardous areas. Reduced voltage starting can reduce the amount of inrush current, which can reduce the risk of ignition. Consider the use of variable frequency drives, or VFDs, for motors in hazardous areas. VFD can improve energy efficiency and reduce the stress on motors. Consider the use of predictive maintenance techniques to identify potential problems before they lead to equipment failure. Predictive maintenance can help to improve the reliability and safety of the plant. Consider the use of risk-based inspection techniques to prioritize inspections based on the likelihood and consequences of failure. Risk-based inspection can help to focus resources on the areas of greatest risk. Consider the use of safety instrumented systems, or SIS, to provide automatic protection against hazardous events. SIS can be used to shut down the plant or to take other actions to prevent a hazardous event. Consider the use of human-machine interfaces, or HMIs, that are designed for use in hazardous areas. These HMI are designed to be safe and reliable in hazardous environments. Consider the use of training simulators to train personnel on the operation and maintenance of the plant. Training simulators can provide a safe and realistic training environment. Consider the use of virtual reality, or VR, technology to train personnel on safety procedures. VR technology can provide a realistic and immersive training experience. Remember to document all safety-related decisions and activities. This documentation can be used to demonstrate compliance with codes and standards and to improve the safety of the plant. Stay up to date on the latest safety technologies and best practices. The field of safety is constantly evolving, so it is important to stay informed about the latest developments. By following these guidelines, you can help to ensure the safety of the natural gas processing plant and its personnel. It is crucial to remember that safety is paramount in such environments and a proactive, comprehensive approach is always best. Firstly, always prioritize safety above all else. Secondly, consult with experienced professionals. Thirdly, stay informed and adapt to evolving standards and technologies.